Okay. So pay attention maybe right at the insert at the bottom, where we're going to go really with this. The most expensive, the most difficult program DoD has tried, okay, to modernize all three components of those systems. Okay, we're going to try to understand quickly what's going on with the modernization. And to do that, I'm going to show you three very short film clips. Okay, you're going to see two bombers, one missile, and one ballistic submarine. And we want to talk about the risks and the cost, because that's where our tax money is going. And when we talk about money, it's billions, okay? So just as a reminder, this is a quick overview of the amount of nuclear warheads that exist. As you can see from the top, the US and Russia, more than 5,000 warheads. Underneath that, China, at about 400 or so, is the upcoming monster. Okay, it's not 400 anymore, it's 500 or more, and they're increasing it at a very high rate. And then, of course, Pakistan and a few nukes there, and we have, going down at the bottom, North Korea and Iran. Who knows what Iran is doing at this point, okay? Now, these are warheads, not delivery weapons, not the mechanism, okay? So kind of an overview of why, okay, to deter. You have to have a credible system, okay? We've been doing this with the Russians for what? From the 50s, the 60s, and so on, okay? At one point, it was known as MAD, mutually assured destruction. And so as you think about this whole thing and the amount of warheads, it's absolutely madness, okay? So your system must be credible. It must be able to do substantial damage. You cannot have an accident, okay? And our triad is the bomber, the land-based ICBM, and the SSBN, which is the nuclear submarine that's armed with intercontinental missiles, okay? Also known as the boomer, okay? So brief history going back with the bombers to the 1950s. You'll probably recognize Strategic Air Command in there. B-29 started way back when, up through the current B-2, the stealth bomber, okay? And then we started with the Atlas way back and went through a series, and now we're at Minuteman. We started in the 60s with the Polaris boats, and we're now at the Ohio class, and we're going to go one more class with the submarines. Just to stop for a minute and look at what does $1 billion look like, okay? And so the programs we're going to talk about are ballpark numbers, okay, because we really don't know exactly what they are, and they're change all the time. In any event, the numbers are very big. So just as a fun example, if you laid $1 bills end to end and you laid them around the equator, how many times would $1 billion go around the planet? Anyone make a guess? 3.8, almost 4 times. Okay, can you imagine laying dollar bills across the Atlantic, the Pacific, Africa, et cetera, until you got to $1 billion? And so the numbers that we're dealing with here are billions. So let's start with the bomber fleet. Okay, our old buddy up in the left-hand corner, the B-52, and the B-1, and of course the stealth bomber. Okay, right now there's 72 B-52s, about 45 B-1s, and only 19 B-2s. They started off with 21 and crashed 2, okay? I don't know how many are on alert, like we used to see in the world of Strategic Air Command. They're going to phase out the B-1 and the B-2, okay, as time goes on. Are they affordable? Probably not, as you'll see the numbers. And are they effective? Well, we've had history from the B-52, and the other two kind of buried somewhere in the archives as to what happened to them. Okay, let's remember the buff, the big, ugly, fat fellow, right? Okay. And dropping all those bombs in Nam and so on, and it's still there. And guess what? It's going to stay there. Okay. So why? Why does USAF want to keep it? Flexibility, okay, you can drop the 500-pounders or nukes. Range, it'll go over 8,000 miles. Payload, over 70,000 pounds. It's a big machine, and you can change it, but you have to spend money. They're looking at partnering it with B-21 Raider. That's the new stealth machine, okay? And of course, I wrote it in smaller letters down there that the Air Force flies airplanes. And don't forget that, okay? Let's see what's next. Oh, yes, flexibility. Okay, that airplane is so big, it stands out on a radar like unbelievable. Okay, you cannot get close to the bad guys with all the anti-aircraft missiles, et cetera. So in this case, that rotary launcher in there contains 8 cruise missiles. Okay, that bomber can drop them anywhere from 1,000 to 1,500 miles away, and you can put 2 or 4 more under each side on the wing platforms. So the big deal here with the B-52 is it's a cruise missile carrier. One more. There's a new weapon, hypersonics. Now you can look at that missile hung underneath there as maybe a small version of an ICBM, okay? And up at the front end, buried behind that nose cone, is a hypersonic glide vehicle, okay? So the bomber drops it, the rocket motor's light, it goes up several hundred miles, gets up to Mach 5 or 10 or 20, and then comes down very rapidly. So that's another reason for keeping the B-52. So let's see what's going to happen to the B-52.
The Boeing B-52 Stratofortress has patrolled the skies for the U.S. Air Force for the better part of 7 decades since its February 1955 introduction. And now, the strategic bomber is currently undergoing some improvements aimed at keeping it in the skies even up until the century mark. Part of the key improvements includes a major re-engineering project so significant that the designation of its most recent variant, the B-52H, is set to change after almost 2 generations. This development has left everyone in the military aviation industry shocked. Here's why. The Air Force recently revealed plans to have a fleet of 2 capable bombers before the end of the 2030s. The Air Force aims to replace the aging B-1 Lancer and B-2 Spirit bombers with its latest stealth bomber, the B-21 Raider. The other is the B-52, but after all those years of service, its age had begun to show, and the Air Force realized that it needed to overhaul its operational fleet. In what is the most sweeping revamp of a U.S. bomber fleet in more than a generation, the U.S. Air Force announced a $48.6 billion overhaul project for the B-52 is underway, involving extensive modernization efforts to upgrade a significant portion of the aircraft. The goal is to ensure the operational viability of the B-52H variant until at least the year 2060. This ambitious plan would extend the lifespan of the bomber far beyond its original expectation of about 2 decades, allowing it to remain in service for nearly a century. Following its upgrade, the B-52H would be redubbed the B-52J, according to the Air Force's fiscal 2024 budget documents. And a key to this upgrade would be the replacement of the aircraft's original Pratt & Whitney TF-33 engines. The TF-33 engines are powerful engines, and they were revolutionary back in the 1960s. But right now, they are quite expensive to maintain, and nowhere near as fuel efficient as modern engines, so any overhaul to the B-52 without an engine change would just be a waste of money. The engine, which Boeing has selected to replace the TF-33 engines, is the new Rolls-Royce F-130 engines, and $2.6 billion has gone towards the development of the engine in what is being called the Commercial Engine Replacement Program, or CERP. The F-130 engines are expected to be much quieter and more reliable than current engines, and Boeing and the Air Force wouldn't have to seek outdated supply chains for spare parts anymore. And associated subsystems such as the engine struts and nacelle, as well as the electrical power generation system, are also set to be replaced. The B-52J will also have its systems upgraded with a modern ESA radar variant to replace its current APG-166 radar, improved avionics, new digital displays, long-range standoff weapons such as the hypersonic attack cruise missile, communication upgrades, and much more. The Air Force expects the first ground and flight tests of the B-52J to begin by late 2028, and for more of the B-52s to receive their engine upgrades throughout the 2030s. The total cost of the SERP upgrades is estimated to be anywhere between $11 billion and $15 billion. But before
The B-52 will live forever, okay? As long as we're willing to spend enough money. So let's see what's next. Stealth. Okay, you can't see it. So we started off like in the 1960s, way up at the top, okay? And there was a technical paper that was put out by, guess who? A Russian scientist, okay? That served as the foundation for building those first stealth airplanes. And so it sat in the archives for a while before somebody noticed it and said, oh my goodness, look at this. And so in 1981, we flew, and those numbers are when there was a first flight, okay? The 117 attack fighter, and then the B-2, and the F-22, and on the way down to our new strategic bomber, the B-21. Now, in that lower left-hand corner are kind of two issues. The time it takes to field that machine and its cost, okay? It's way too long. We're looking at development times of 8 years, 3 or 4 years of testing. And so the bad guys have a chance to look at it and devise defense against it for all that time frame. So moving on, maybe we ought to talk about the original stealth hunter. Now, since I had that falconry license, kind of old weird Dirk, right? On the left side is the B-2, side view. On the right side is a peregrine falcon. Kind of looks the same, don't they? Okay. Now let's look at the peregrine for a second. It is known as the fastest bird alive, 200 knots going straight down. And so as a quick overview, let's assume he's looking for lunch, okay, or dinner, and doing a tail chase against a duck or a pheasant from a zero start, he's probably going to lose. But there's a way to get around that, and that's to circle around up there till you spot lunch, do a split S for you fighter pilots, roll over, push the power up, go straight down, 5G pull out, come up behind lunch, knock it out of the air, do a high-speed pull up to kill off speed, come down and have lunch. Okay. Now, if the B-2 crew tried that, they may not make lunch next time. Okay. So that's the history of the peregrine and the B-2. Here's the B-2.
Imagine a bomber so advanced, it can sneak past even the most sophisticated defenses, adapt to future missions, and do it all at a cost that won't break the budget.
Don't believe that.
The B-21 Raider, America's latest stealth bomber, and a likely game changer in modern air power. Now, this isn't just a concept airplane. The Raider has been flying for over a year, and we've even seen photographs of it flying at high altitudes. Here's the thing. The Raider is not just a weapon. It's a glimpse into the future of warfare. This aircraft could take on roles originally designed for cutting-edge fighter jets. So what makes the B-21 so revolutionary? And could it redefine how the U.S. Air Force fights its battles? Let's dive in.
Pilotphotog.com.
Despite similar appearances, the Raider is no ordinary bomber. It's designed to break through the very toughest air defenses and strike targets anywhere in the world. But what makes it truly stand out are 3 groundbreaking features that set it apart from anything we've ever seen before. Number one, stealth like no other. The Raider builds on the legacy of the B-2 Spirit, a bomber that features state-of-the-art technology designed to evade even the most advanced radar systems. Despite being in service for over 35 years, we still don't know just how stealthy the B-2 really is. Some experts say the B-2 is nearly invisible to detection. The combination of a tailless wing, top-mounted jet engines, along with special radar-absorbing materials, virtually make the B-2 a flying black hole in the sky. The team at Northrop basically took all these lessons they've learned, along with massive advances in computer technology, and made the B-21 Raider. So when it comes to stealth tech, the Raider will make the B-2 look more like a biplane as compared to an F-15 Eagle. Essentially, whether facing high-tech defenses or contested airspace, the B-21 is built to stay invisible. Number two, future-proof design. What's really exciting about the Raider is its modular design. The B-21 is set up to integrate next-generation technologies as they develop, such as advanced sensors, artificial intelligence, and even directed energy weapons or lasers. Think of the Raider as a flying gaming PC. You can upgrade the RAM, add a video card, or even an extra hard drive, yet you still have the same box the computer came in. This makes the B-21 much more than just a bomber. More on that in a minute. Number three, surprising affordability. All right, it's time to talk money. When it comes to bombers, their toughest opponent isn't usually surface-to-air missiles or even enemy fighters. It's perhaps the oldest adversary there is.
You believe them? Let's take a quick look at the B-21 program. Okay, contract 2015. Okay, so I can get around the problems with bullet charts by, oh yes, I'm sorry, around the problem with bullet charts by just bringing them in one at a time. So there's where it started. First flight, remember what I said, 8 years later. Okay, too long. And maybe another 4 years in flight test and so on. Okay. They're in initial production phase, which means I think there's about 4 or 5 bombers out there now in flight test and ground test and so on, okay? And looking at their manufacturing process. Step back for just a minute, okay? The B-2 initial quote on the contract was $440 million for 132 buy. The actual cost that came out with those 21 airplanes, over $2 billion a piece, okay? The B-21's initial cost was what, $553 in 2019 dollars, okay? Right now they're looking at $700 million or more each, okay? And they're gonna buy, they think, 100 or more. With R&D, Air Force is gonna spend $32 billion or more through 2027. Program over $200 billion. Kind of an interesting side, if you've dealt with contractors, is that Northrop took a fixed price contract with that machine at the beginning. They have lost over $1 billion on their books, okay, in the hole. Let's move on to the new ICBM, Sentinel, okay? Some background here. It's going to replace the old Minuteman. Now, Minuteman has been updated continuously, and so the big decision lately was to continue the update, okay, or eliminate it. There has been a lot of pressure to stop the land-based ICBM program. Why? It's dangerous because in various views, it's launch on warning. And if the warning is not good and you launch, you've got a big problem, okay? And so there is a variety of organizations. This one, the Lawyers Committee, okay, was pressing Congress should stop the funding for that machine, okay, for those reasons. Okay, launch on warning. There have been various problems in the past where The Russians thought we had launched, and we thought the Russians had launched. And there was a couple of them where it came fairly close. The Sentinel program, I kind of invented this, 3 major segments: the missile, ground, and command, control, and communication. Okay, that's not official, but for this purpose, we can talk about all 3 quickly. They're going to replace all 400 missiles. Okay. There are 450 silos, which means 50 silos are now empty. 600 facilities and a huge amount of land space. So the idea here basically is to look at both those pieces and see what's going on. The program, so here's the money, folks. The program baseline in 2020 was 96 billion. Okay. IOC, initial operating capability, in 29, everything finished by 36, and they're going to operate it until 2075. The dollar estimates, if you can believe that, this is what they're confessing: a huge uncertainty in the amount of money, and we're going to see why in just a minute. There's strict nuclear safety requirements, security requirements with these programs like this. You can imagine why. And the current Minuteman III program has to remain online until they're finished with the upgrade. Here is a view of just the missile.
In 2030, when it's supposed to become
just the missile.
The Sentinel will be used from the existing ICBM silos that the U.S. Air Force operates. Currently, the U.S. operates some 450 silos in 3 separate vast silo fields. There, it deploys 400 Minuteman III ICBMs, which means some silos are currently empty, but maintained. Minuteman III is an old missile design. It started development in mid-1960s, being based on even older Minuteman versions. Most changes focused on a new 3rd stage and a new re-entry vehicle system. There were some other updates to the missile since then too, but now in the 2020s, we're talking about the 50-year-plus old system. By the time Sentinel comes, it will be 60 years old. U.S. Strategic Command described the GBSD program, which gave birth to the Sentinel, as having 3 goals: to improve upon the Minuteman III in range, payload, and accuracy. Previously, nuclear weapons treaties made large missiles with many warheads not very cost-effective. But with nuclear arsenals shrinking overall, there is again merit to fielding missiles with many warheads. The current U.S. silos could support larger missiles too, as they were engineered with such an option in mind. Actually, near the end of the Cold War, the U.S. had a newer ICBM deployed in existing silos, the Peacekeeper, which was a larger and a more capable missile. But due to the cost and perceived lack of need, those were retired after just 20 years of service. So now the Sentinel is coming, and it's not really some large, super capable missile. While exact dimensions haven't been disclosed, everything known so far is pointing to a missile smaller than the Peacekeeper, and to a missile only slightly larger than the Minuteman III. Currently, due to the treaties, some Minuteman IIIs carry 1 nuclear warhead each, but they were designed for up to 3 warheads. The Sentinel, according to the U.S. Air Force, will be similar. It will nominally field 1 warhead, but will be designed for up to 3. Compare that to the larger Peacekeeper, which was designed for up to 12 nuclear warheads. Roughly comparable in size to the Sentinel, the Russian Yars missile carries up to 4 warheads, though Russia has even larger ICBMs carrying more. China's DF-41 missile may also be more capable due to its size. Its warhead count is at least 3, but as it's essentially unknown, it could easily be more. Now, a 3D rendering of the Sentinel has been released by the US Air Force, and it shows a configuration somewhat similar to Minuteman III one. Instead of a missile like the Peacekeeper, which has the uniform diameter for all its stages, the Sentinel seems to have progressively smaller diameters for its 3 stages. If that ends up being true, it will explain why the warhead count is described as up to 3, with the final stage likely being similar in diameter to Minuteman III stage, and the middle stage possibly being as wide as the Minuteman's first stage. Minuteman III had the same diameter for its middle and final stage. That might imply that
That gives you an overview of the missile, okay? We've been building missiles, NASA, the military for quite a while. There should not be a big problem with cost overruns, et cetera, on the missile. But the next part is the problem. A quick view, okay? This is the current Minuteman system. There are 400 missiles at 3 sites, as shown there, okay, in Wyoming, Montana, and North Dakota, okay? Each one commanded by an Air Force colonel. What this looks like is on the left side is the launch control facility. On the right side is the launch facility or the silo, okay? Each launch control facility has responsibility for 10 missiles, okay? 3 warheads apiece. If that's the case, you're looking at 30 warheads, okay? And maybe you've seen this picture before, the launch control facility with the 2 officers, usually maybe a captain and a first lieutenant. Everything you see in there, I guess that's not going to work. All the equipment behind them, in front of them, et cetera, is undoubtedly going to be replaced by the new program, okay? Everything. That's going to be part of the problem. Those crews that sit in there, it's pretty amazing. That young captain or lieutenant who's the commander of that crew is going to sign, when they're down there, for 10 intercontinental ballistic missiles with their warheads. Go ahead. Maybe we can add some after I'm through here, okay? So look, the what? Hey, if I'm off, let me know, okay? I was not a missileer, but the idea here is what's going on with the cost and what they're doing, and how long is it going to take? So that is going to be replaced, okay? Let's take a quick look at one of these missile wings. The 3 components up, there's 3 squadrons. Each squadron has 5 launch control facilities or 50 missiles, okay? And so that's 1 USAF wing. If you look at or think about this, every one of those is going to be replaced. It's going to be dug up, new wiring, et cetera, okay? So kind of get a mental picture of what that might be when we look at the next slide, which is going to be a picture of just one base, Francis Warren, okay? And it's scattered across Wyoming, Colorado, and Nebraska. Each one of those red dots on there is either a missile silo or a launch control facility, okay? Now think about replacing all the wiring, for example, between those, okay, to start with. And so what that might look like is thousands of miles of new trenches. And those silos, et cetera, a lot of that missile components there are on private land. And the Air Force, the government had to negotiate with the landowners way back when to put the current system in place. And so now they got a big problem over negotiating access, okay? And so if you go back to that previous slide with all those dots on there, putting all that together in that way. Now there's the one I ran across that's kind of interesting. Last slide. Down in the right-hand lower corner is 1 silo, okay? And with its fence around it, and way in the background is a whole line of wind turbines. So how could wind turbines be a big problem for the missile system there? Well, I guess it turns out that if there's an alarm goes off from that security system that's around the site there, then what has to happen is Air Police Special Squadron with their helos have got to get out there ASAP to find out what happened. Now, the weather might not be too good, and they're racing along at real low altitude with their helo, and you've got all those wind turbines out there that are 600 feet high, a problem. Now they've got another problem to deal with in addition to trenching. So let's look at the risks for a minute, okay? They want to use those existing launch control facilities and silos. They don't know whether those silos or not are capable of going forward for all the period of time for another 50 years. There might be water table down there that's been working on that concrete for a long time. So there's a big problem there. You saw what we talked about, dig up and replace, okay, with all that cabling. What's next? Software development. That's kind of the world that I lived in for quite a while. It's a big problem, and it's a big problem here because of the nuke security requirements and because of modern digital technology and putting all that together in a secure way. The security overall, you can imagine with all those acres, all those contractors going on, et cetera, all those changes, okay, the security that has to happen that Northrop and its subcontractors have to deal with, including the new digital systems. You're going to be operating 2 different missile systems at the same time, okay? All the training and the overlap, what kind of issues will that cause? Okay. And of course, we've all heard the supply chain and availability of skilled workers. It's a big problem. You look at those major DoD contractors, Northrop, okay, General Dynamics, and so on, they're still having major problems. Oh, here's a nice one. Per the program office, their master schedule isn't worth a damn. Can you believe that? You cannot manage the program because of their ability to work schedules. One last bullet chart, I think, okay? They have a big problem. They breached Non-McCurdy Act. That act was put in place by Congress years ago for big programs that overrun their budget by at least 25% and overrun the schedule a lot. They ran it way up, 37% or more over budget. Lots over budget, okay? And so what happens, and it's called a critical breach in this case, okay? And you have to get up and go to Congress and pray, okay? And confess. And so whatever has to happen, but because it's a national security program, you can't stop it, supposedly, okay? So look at where the costs are. I've seen as high as $140 billion. Okay, and so Air Force has got to go find some money. And so Frank Kendall, who was, or maybe still is, the Secretary of the Air Force, he's a pretty smart guy, okay, says, this is the biggest, most expensive program I have ever seen and has the largest risk. Oh, the program manager, the colonel, is taking the hit. Okay, because apparently he did not follow procedures. And if I can make a guess, what he probably tried to do was move money around without authority to do that. Okay, because I know a colonel who was going to get a star a long time ago who did that, I think, in a program and thought he could move money around as needed and not tell anyone. And so that didn't turn out so good. Okay. So they say that missile itself is not a problem. It shouldn't be. We built missiles all over the place. So Northrop is going to deliver 659 missiles when the contract is through. So maybe we can get off of Sentinel and go to our boat, the last part of the nuke triad, okay? And so the new Columbia-class SSBN is on deck here. And what the numbers seem to be is that the Navy is carrying at least half or more of the nuke warheads for this country. Okay. So there's the Columbia boat being built, the first one. It's called the District of Columbia, and it's almost 2 football fields long. It's a little wider than the existing Ohio class, and there's still a crew of 155. So I'm just about at the last of this. There's one more video that tells you about the new Columbia-class boat.
The Columbia-class ballistic missile submarine is expected to provide several improvements over the Ohio-class submarine for the U.S. Navy. Some of these improvements include enhanced stealth capabilities, increased missile capacity, improved communication and surveillance technology, and overall modernization of the submarine systems. Additionally, the Columbia-class submarines are designed to have a longer service life and are expected to be more cost-effective to operate and maintain compared to the Ohio-class submarines. These advancements are aimed at ensuring the U.S. Navy's strategic deterrence capabilities remain robust and effective. Since the Ohio class first started being pushed into the water to give international asshats of the red variety moments of pause, the clock has been ticking on their efficacy as a nuclear deterrent. Over the past 40 years, America's varied enemies have had quite a long time to build up a sound profile for various boats in the Ohio cohort. And while Ohio boomers are still arguably the most quiet SLBM haulers in the business, submarine technology has progressed significantly in that time. You think of quiet submarines and you come up with something like the Kilo boats from Russia, which have been gradually updated when new ones are built, which, optimally, is how submarine warfare should work out. As new technologies are developed, you build them into new submarines. In American procurement, this has been evident in the Virginia class, of which 9 more were just recently ordered, and 8 of them are Block V, or the 5th iteration of the Virginia design, where each block incorporates new abilities. However, with the design requirements inherent to an SSBN, which include frequent and lengthy patrols while remaining silent under power, being a lot pricier than the smaller Virginia attack boats, the cost of designing and building an entirely new type of boomer has to be offset by how long the class can stay in active service. Changes incorporated into the Columbia's 16 launch tubes for SLBMs, down from 24 on the Ohio's. Pump jet propulsion that does away with traditional free-spinning propellers, which have always been the acoustic trouble for any submarine. Bladed propellers create cavitation, which is tiny air bubbles forming on the surfaces of each blade, and when those bubbles collapse, they make sound that can travel through the water column to any nearby submarine and give away your position. They also deteriorate the propeller's surfaces over time with pitting. The other problem with spinning propellers is how they're mechanically linked to the boat's power plant, necessitating a long prop shaft that can go out of alignment and create another acoustic signature. Pump jets use electric drives instead of mechanical ones, and this change vastly limits the number of acoustical problems. Columbia's will also be fitted with an upgraded sonar package, the large dome at the front of the boat that is used to listen for other submarines and navigational hazards. And this new version of the large aperture bow system will be able to single out a fish with indigestion 30 miles away. Also included in the build is multi-axial steering via the X-shaped control surfaces at the boat's stern, which, when combined with the traditional dive planes on the sail, will increase the boat's maneuverability underwater without a gain in propulsive force. Theoretically, anyhow. The nuclear power plant will be state-of-the-art and will not need refueling during the expected lifetime of the boat, unlike the Ohio class, which needed to be taken off the line and disassembled for refueling halfway through their service lives. All of these advancements will combine into a boat that should be able to carry out 124 deterrent patrols over its 42-year expected lifetime, or roughly 3 patrols a year, each lasting 3 months, allowing for a 1-month servicing period between departures. With the Chinese surging the manufacturing of their own submarine fleets, it is vitally important that the Americans maintain their combat deterrent edge beneath the waves, particularly in the Pacific Ocean and South China Sea, where the next international conflict is likely to kick off.
Okay, so 21, they started building the boat. 22, keeling. 27, completion of District of Columbia, service in 2030. Okay. The cost for that first Columbia class, $15 billion, give or take. Okay. Total program over $100 billion. Each sub, maybe $99 billion. Okay, maybe. Life cycle cost over 300 billion. Seems that they're still going to have they too are having cost and schedule issues. And so with the last one, the sub fleet is a critical balance against the enemies, okay, and provides underseas diplomacy. Maybe one last comment about this whole thing. If you remember back, the bombs that were dropped on Japan were about 15 and 20 kilotons of TNT, okay? Those warheads on Minuteman, et cetera, are anywhere from 300 to 500 kilotons, okay? It's just unbelievable, the difference. And back in the 60s, I think the Russians dropped the largest hydrogen weapon, 58 megatons, a huge explosion, okay? The whole thing in terms of, if you want to stand back and look at it, in terms of nukes and explosions and money, it's pure madness. Thanks for listening. I hope you enjoyed it.